Mr. Crispin here once again, and welcome to my workshop. Now, you may remember me from such videos as regrinding a lathe spindle nose, setting a tool post grinder, or perhaps from the discussion topic, are you suffering from bar sag? Now, if you do remember me from those videos, and if you have seen those video productions, then you will be pleased to know that today's video is the last one in the series. In this video I will be finishing the whole lathe grinding job by regrinding all of the work holding surfaces on my 3-jaw chuck. Now, this is less of a how-to guide and more of a experiment on camera. There's quite a few topics to cover, so with all that said, let's make a start. To start the process, I have cleaned everything. Now, why regrind a 3-jaw chuck in the first place? Well, partly so that the interaction between the jaws and the component is even, so that you get a good contact all the way along the jaw with the pressures holding in a parallel fashion rather than at one end or the other, but mainly to regain concentricity. Now, I could have reground this chuck as it was and gained concentricity. I didn't have to bother stripping it down. I could have loaded it onto the lathe, reground the jaws, it would have been concentric. But for how long? The word really is consistency. I need the chuck to consistently hold things concentrically, and of course the most consistent state is the clean one. So my plan here is that by cleaning it first, when I reassemble it, all the contact faces will be proper metal to metal with no chips or grease in between. I will grind the chuck all clean, and then going forward into the future, if at any point I lose concentricity through ingress of chips, grease, debris, swarf, I will be able to regain concentricity by cleaning all the pieces. So that is my basic outset. I'm starting with a clean condition because that is the repeatable one. So far, all the grinding that has been done in recent videos has been done by means of mounting the wheel directly to the spindle as such, with blotters, spacers, etc. either side. To grind these chuck jaws, however, I am going to require some kind of extension because the top slide face prevents much wheel getting within the jaws. So what I have chosen to do is take this collet type extension that belongs to the kit of the Dumore Tool Post grinder, and I'm going to use this to create an extended spindle. That is the wheel arrangement, and as you can see, that's going to allow plenty of room to get right through and even past the jaws. The chuck is prepared, the wheel is formed, so I'm now going to take this, install it on the lathe and set up for the grinding operation. So this brings me on to the most important topic of the video, and that is the topic that falls under the title preloading the jaws. Somehow I have to preload these jaws so that they are stationary during the machining process and so that I can get the wheel down the middle. Now, the way in which I preload these jaws has consequences, and to begin the discussion on that, let's consider exactly what the actual aim is here. I'm going to aim to grind these 3 surfaces in such a way that when I put a component in there, it holds it concentrically and firmly. And to hold that firmly, I need a parallel grip, and if there are any biases in clamping forces along the length of the jaw, I need those biases to be towards the front so I get the best bite. Now, with that in mind, let's consider some options. So one way of doing this might be to place a ring over the outside of the jaws and then wind in the reverse direction to clamp the ring as such. So the jaws have wound out and I'm clamping on the inside of the ring. Now yes, that has held the chuck solid, and yes, it allows access. However, there is an inherent flaw in this method, and that is that I am grinding surfaces for a forward clamping motion, but I'm preloading the chuck in a reverse clamping motion. So inherently there are going to be some errors in doing that. So somehow what I have to do is to simulate a forward clamping motion, because the surfaces I'm producing are for a forward clamping motion. The next simplest way of doing that might be to take a piece of material and make use of the cutouts that are at the backs of these jaws. So for instance, I could put a piece of material down the chuck, find the cutout in the back and clamp it up as such. So now the jaws are preloaded in the forward clamping direction, and I have got the bore clear, at least for the length of chuck jaw that I require. But I used the word earlier, clamping bias, and the problem with clamping at the back here is that I would be producing a parallel and concentric grind, yes, but any bias is actually towards the back of the jaws, where, as I said, I wanted it towards the front. So that is also not going to be ideal. Hopefully between those two examples, what I have demonstrated is that the final solution needs to be a method that is achieved through forward clamping of the jaws, and also it needs to be biasing the front of the jaws rather than the back. So this topic is not a new one, and anyone familiar with boring soft jaws will already be aware of it. And to show you a few examples, I've prepared a couple of pictures on my phone. This is a modern lathe chuck with soft jaws, so these jaws are going to be bored to whatever profile is required, and exactly the same thought processes apply to the soft jaw boring operation. Now the route people go down with these professional chucks is to make use of the holes and use a piece of apparatus called a boring ring or a boring spider or whatever other salesman type name they happen to have come up with. And an example of a boring ring can be seen here. So it's just a ring with pegs on it. The pegs fit in the hole, and then as you tighten the chuck forwards, the pegs press in the holes and it allows you to preload the jaws. A close-up example can be seen here. So the peg's gone in the jaw, you tighten the chuck up and it leaves the centre clear whilst preloading the chuck in an appropriate way. Now, in addition to those soft jaw methods and thoughts, I've also studied the work of Robin Renzetti, who has shown various methods that he uses, and one of the methods he has shown is the use of dowel pins. So obviously these jaws have no holes in them, but if you could create somehow a dowel pin coming out of the jaw, you could then clamp on the outside of a ring, so you're loading the chuck in the forward clamping direction and you're clamping towards the front of the jaw. So if you could somehow produce a dowel coming out of the front of all three jaws, that would give a scenario where you could achieve the proper preloading arrangement. So I have set my mind to work over various times thinking of a solution, and my first thought was to drill a hole in the back of each jaw somewhere around there and then insert a dowel. And I came to the conclusion that even with the best modern carbide, I was probably going to make a mess of the jaws because they are very hard, and so I opted not to drill holes. I then thought about trying to add some material. So what if I could create a block of mild steel that had grub screws on the side and pincered itself on, and then in the front of the mild steel you put the dowel pin, and then obviously the ring comes in. So that was a strong favourite, although I thought still it's a little bit unpredictable to just hold on the side, particularly when they're spinning around. Would it move? I don't think it would. I think it would be successful, but as I was thinking through these things, I came to my final vision, and that was to produce something that I have named the MrCrispin jaw dolly, and it looks like this. I'm just producing a video to show how I made them. There's 3 of them, and what I have done here is to make use of some of the jaw geometry and to manufacture a corresponding hook. So if you notice on these jaws, as typical of most chucks, there is an angle leading into the clamping face. So the hook portion of the jaw dolly slides over the angle, and then through means of a grub screw that is going down the middle, I can clamp the jaw dolly on such that it's hanging on those angles. I have of course made 3 of them, so if I just position these in position, I will then complete the demonstration. Ring, and now I can clamp the ring. The chuck is being closed in a forward clamping motion, and the clamping is going on at the front of the jaws to give me the right kind of clamping bias. This of course allows access for the grinding wheel to go up and down the middle, as the jaw dollies and ring have left the key surfaces exposed. And a close-up alternate view of the jaw dolly clamping system can be seen here. That is all the jaws now fully reground. Okay, checking down the bore. I am 2 6/10 past 0. The dimension of course is irrelevant. I'm just taking a reference. And down here 2 4/10 past 0, so there's 2/10 of a thou, around about 5 microns difference front to back, which is highly acceptable. Okay, so that concludes grinding of the bores. In total that was a total material removal of 120 microns, which you're getting on for 5 thou, 7 passes with spark out passes to finish. Whilst it's situated like this, I'm actually going to come in, and in fact this ring will work fine. I'm going to come in and I'm going to grind the faces of the jaws to give me a nice square reference. So with that complete, the jaw dollies are now redundant, and I'm going to move on to working on some of the other jaw geometry. Before I go much further, I will need to redress the wheel. Seems to be holding up okay. And first of all, I'm going to work on the other 2 sets of edges of these standard jaws, which are this diameter and this face, and this diameter and this face. Now the thought process will be extremely similar, the only difference being this time that I need to make sure the preloading is done using a outward reverse motion, because that is the direction in which you would be clamping when clamping on these outer edges. So this will be fairly simple, much shorter length of a hold than the inner jaw, so a little less thought required, but basically I'm going to clamp a ring outwardly like this on this surface and grind these faces, and then once I've done that I will clamp a larger ring on the outer faces, and then I'll come in and grind this face and this face. it would appear I've missed out a step in the thought process, and let me show you what it is. I think I've been lucky with the first set of external diameters I ground, but here what is happening, the grinding wheel is just touching on to the outside corners, and in the position where it's just touching on, there's a gap between the wheel and the jaw of roughly 1 millimetre. So basically the radius at which these jaws were manufactured is quite a bit larger than the radius I'm holding them at here. So if I was to proceed with the grinding as set up here, I would have to do a radial infeed of over 1 millimetre to describe a new circle. Although that's possible, not only is it quite a lot of grinding, I'm also not sure whether I'm going to affect the hardening. I don't know if these have been case hardened. If they have, I'll be well through that. So what I think I'm going to do is try and find a larger ring to bring the radius right out and allow me to stick with the radius that Pratt Burnerd originally picked. Right, I have been racking my brains for over 20 minutes and I've decided to stop before anything falls out. What I have done, however, is found a solution that I think is going to work. The simplest option here would have been to have a ring of the right size to set the chuck to, but in absence of that I've come up with a workaround. What I'm going to do is I'm going to put the jaws into this position on that ring, lock the chuck up, and then I'm going to grind the outer surface of the jaws out here, and I think that will actually be a handy surface to have trued up anyway as a get out of jail means. But with that trued up, I will then be able to use a ring which I have managed to find, and that looks like this. And in there, what I've done, I've taken a scrap brake drum off my Series 3 Land Rover and I've cut it in two. So that's left me with a ring that I can put over here, and then of course I can use that to wind the chuck outwards, and that brings these surfaces to about the right radius for me to true them up. So we'll have a quick shot of me splitting this with an angle grinder and then it's on with the job. Right, well I was supposed to be in fast forward finishing the job, however having completed these jaws I've come to put the external jaws in, and unfortunately they don't fit in the chuck. Now I've had a few thoughts, but basically I think these jaws can't belong to this chuck, and probably they never have fitted. in the year I've had this machine operational, I've never had to use these, so I'm not quite sure at what point in history this mix-up has happened, but I'm pretty certain that jaw has never been in that chuck. So what I'm going to do is a bit of, or shall I say what I have done, is a bit of analysis. I've measured up a few dimensions, both on the jaw and the chuck, and checked out a few bits here and there. And what I have decided is that this slot is too narrow on both sides and on all three jaws. So I'm going to go to the surface grinder and just open this slot up by a thou, 25 microns, and see if that solves the problem. Following the use of a precision tapper, I have got these so they're lined up, plus 4 microns, plus 2 microns, plus 2 microns. With that said, I am now going to carry out some grinding. With the grinding complete, I shall now give everything a clean, reassemble the chuck and pick up where I left off in fast forward. Right, with a final strip down clean again and re-grease, I'm now ready to inspect the final result and see if any of these jaws are now running concentrically. I've got here it's actually a blank for a form milling cutter, so this would have a profile ground into it. This is, as I said, a blank. Let's install this into the chuck. Right, well I was hoping for a little better than that. That's about 0.1 of a mil. I shall have a little think and come back. Right, well I found something interesting. So as established, as I tightened it up just before, I've got a run out. In fact, if I zero that off there so it's a little clearer, a run out of 0.1 of a millimetre. If I slacken the chuck and tighten it up again, but using a different position, I have a run out of 0.08 of a millimetre. And if I use the final remaining position, I have a run out of 40 microns, a thou and a half, which is much more like it. So my theory is here that because when I tightened up using the jaw dollies on the disc, because I tightened up using one of these, the jaws are ground concentrically in reference to being tightened from this position. So whatever slack and play there is in all the various mechanisms, that has led to a difference in run out depending on which piece you use to tighten it. What I will just do for a brief experiment is just do a sort of a gentle tightening procedure. So this is the good one, as I'm going to call it, but let's start with a different one, and instead of tightening up fully from one location, I'll just snug it there, then snug that one, then snug that one, and go 1, 2, 3. That gives me 60 microns. So depending on whether you do them individually or all together, and depending on which one you pick individually, there is a surprising difference. One point to make: had I performed this check immediately after grinding the jaws, I would have been extremely surprised if I hadn't got almost exactly 0. But in some ways that's a bit of a false experiment, because unless you're going to regrind the jaws before every time you use them, what actually matters is how well can you repeat and get back to a concentric setup after you've had the jaws out a few times, after you've cleaned everything a few times, and that is what I replicated here. So between this inspection and the actual grinding of the jaws, I've had these jaws out, the other jaws in, I've had the back plate off twice. So really I'm quite pleased that despite all those different variables, I can get it to within a thou and a half just by picking the right one here. I was just about to move on and start checking out the other jaw surfaces, but I thought before I do that, how about a quick investigation into the fit between the back plate and the body registration diameter. Now forgive me, normally I advocate not tapping a workpiece while it's in touch with the indicator because it can shock the mechanism, but in this case I'm going to leave it where it is just to see what happens. Try 90 degrees round. Right, well that didn't move at all in any direction. Right, with the back plate theory ruled out, I'm moving on just to see what everything else is like, and I've got a diameter here that I can reference. So, in no particular order, let's see how this responds. Tightening position A, total indicator run out of 70 microns. Position B, total indicator run out of 70 microns. Position C, total indicator run out of 40 microns. So again, there appears to be a favourite. Let's have a look. Now I don't have enough different diameters to test all of these out, but let's just use the indicator straight off the ground surface, seeing as it's already preloaded in the right direction. We have 0, minus 40, minus 40. Back to 0, and here we have 0, 10 and 30. So with this piece held using tightening position C, I've actually got fairly minimal errors. 40 microns here, about 40 microns here, and about 30 microns here. So for a 3-jaw chuck, that is not bad, particularly considering it's been reassembled and cleaned twice. Let's have a look at the opposite jaws. Tightening position A, 40 microns. Tightening position B, 70 microns. Tightening position C, 60 microns. Let's now check these other two out. In fact, one thing I haven't checked yet is the axial alignment. Yeah, they're within 2 microns. I'm not going to bother checking all those different faces out. I'm quite happy with the method for that. Tightening position A, 40 microns. Tightening position B, 50 microns. Tightening position C, 70 microns. Tightening position A, 50 microns. Tightening position B, 70 microns. Tightening position C, 40 microns. Right, that is all the checking carried out. In terms of axial run out, there's nothing to write home about. In terms of radial run out, there's clearly quite a lot going on. Now, my hypothesis is that whichever tightening position was used to set up for the grinding operation is the tightening position that gives the optimal concentricity for work holding. So, for example, if you want to hold a piece between these 3 outer surfaces, then whichever position was used when I ground those 3 is the position that will give the best results. I think the contributing factors to this are mostly going to be in the wear department. I think probably wherever the jaw is on the scroll, I would get a slightly different reading again, and wherever the internal tightening is happening and the play that is associated with that takes place, results in the results we're seeing here. So am I going to do any more grinding? No. I'm quite happy with the process as a whole, and the results are something I will just bear in mind as I use this chuck to do machining work. Well, that's quite enough for one sitting, and besides, Jefferson will be about ready with my evening port, so I'm going to leave it there for today. Now, I will spare you the lengthy conclusion discussion topic which could ensue from this sequence of events. However, of course, commentary discussion is welcomed. Now, just before anybody does type this one out, I will point out that on both disassemblies of the chuck, I marked up the rotational timings of all the pieces. The back plate, the gears, the scroll, all those pieces went back in exactly the same positions and interactions with each other as they were originally in. So that can also be removed as a potential source of error. Apart from that, I'll say thank you for watching. I hope you found this interesting, and see you on the next video.